So in this session we will discuss AS Physics, the subject code when you are appearing for AS Advanced Subsidiary, then it is XPH11. If you are appearing for complete A levels, then it is YPH11. So for you it is XPH11, and that is having three units: Unit 1, Unit 2, and Unit 3. So Unit 1, which is about the material, as you can see, the Unit 1 is about the mechanics and materials. The subject code, the unit code for this one is WPH11/01, and the subject code is XPH11 for AS. The duration for this exam is 1 hour and 30 minutes, and you can appear in January, June, or October sessions. The first assessment was conducted in January 2019. Total marks for this paper, that's 80, and 40% of your AS result based on Unit 1, and 20% of your AS result, A level result based on this unit. The content mainly it's about mechanics and materials, and you will have multiple choice questions, short questions, open response, calculation. Then Unit 2 is about waves and electricity. So in Unit 2 you will learn about waves and electricity. Duration for this exam is 1 hour 30 minutes, so same duration, and again 40% of your total marks of AS based on this, whereas 20% complete A level. And the subject, the unit code is WPH1, and it includes waves, particle of nature of light, wave and the particle nature of the light, as well as electric circuits. The Unit 3 is about practical skills in Physics 1. Duration for this exam 1 hour 20 minutes, maximum marks 50, and total 20% of your A level result based on this. Then Unit 4, 5, 6 are for A2 or A level. So basically the subject code is XPH11 and the unit codes are WPH11, 12, and 13 for AS. So we will start our Unit 1, which is about the mechanics and the material. So in this session, you will learn about the motion, the forces involved in the motion, and the material, the type of the material, and as well as the properties of the materials. That's a full unit. And the subject, the unit code is WPH1101. That's according to new specification. So first, the quantities which we can measure refers to physical quantities. So we have the base quantities or fundamental quantities with their base units. So length is a physical quantity, and the unit of the length is meter, and it can be symbolically represented by small m. Mass is a physical quantity, a base quantity. The SI unit of mass is kilogram, and it can be represented as kg. Time is there. The base quantity is time. The SI unit of time is second, and it can be represented by small s. Electric current, that is, the unit is ampere, and it is denoted by capital A. Temperature is in Kelvin, denoted by capital K. Amount of substance, mole, denoted by MOL. And light intensity or luminous intensity, the unit is candela, denoted by CD. The reason why first five are in a gray shade, because these five are important that you have to learn or memorize. You should know all seven of them, but you should learn first five of them. So any quantity other than these seven is known as the derived quantity. So derived quantities are measured by using two or more fundamental quantities. Then the prefixes which we normally use, if it is 10 power 12, it is tera, 10 power 9 giga, 10 power 6 mega, 10 power 3 kilo, -1 deci, -2 centi, -3 milli, -6 micro, -9 nano, and -12 pico. So when we represent a quantity, we should represent a quantity in terms of the derived quantity in terms of base units. So representing representing the derived quantities in terms of base unit. So how we can represent the derived quantity in terms of base unit? So we have the base quantity and the units. Length is there, that meter. Mass is there, that is kilogram. Time is there, that is second. Current is there, electric current, that is ampere. And temperature is there, that is Kelvin. Other two are there, but that we don't have to use. So these are basically the derived quantities with their units. Now, what we have to do, we have to represent the derived quantity. These are the base quantities with their unit. Now, what we have to do, we have to represent the derived quantity in terms of base unit. So, example, if I say speed. So, first thing, for a speed, you should be able to write a formula. We know speed is equals to distance divided by time. So what is the unit of distance? So first we write the formula. The first step, when we want to represent a derived quantity in terms of base units. So first we'll write a formula and then we'll write the unit. So what is the unit of distance? The unit of distance is meter. And what about unit of time? Unit of time is second. So it is meter per second, or we represent all of them in numerator. So if when I move second in numerator, it will be ms minus 1. So the base unit for speed is equals to meter per second, or ms minus 1. Is it clear? How we represent the speed in terms of base units? Same way, example, if I say force. So first thing, you have to write a formula for force. We know force is equals to mass multiplied by acceleration. So that's a formula. Then when we represent in terms of unit, unit of mass is kilogram, unit of acceleration is meter per second square. So when we simplify, it will be kilogram meter per second square. But this second will move in numerator, so it will turn out to be kilogram meter second raised to power minus 2. So the base unit of force is Newton, but the base unit is kilogram meter second raised to power minus 2. So we can also say that Newton is equivalent to kilogram meter second minus 2. Is it clear? The second example, how we represent the force in terms of base units. Same way, if it was acceleration, the acceleration is change in velocity divided by time. So as acceleration is change in velocity divided by time, first we wrote the formula, then we'll write the unit for change in velocity, that is meter per second, and unit of time is second. So when we solve, it will be meter divided by second square, and if this will move in numerator, so it will be meter second minus 2. So that is the base unit for acceleration, or representing the acceleration in terms of base unit. Another example, if you want base unit for work or work done. So what is work done? Basically, a work done is equals to force multiplied by distance. And we want to represent this work done in the base unit. So this is a formula first. When we write the unit of force is Newton and unit of distance is meter. But Newton is not the base unit. As you can see in the previous example, Newton itself equivalent to kilogram meter second minus 2. So here Newton is equals to kilogram meter second minus 2. This is what Newton means. And then it is multiplied by meter. So when we further simplify, it will turn out to be kilogram meter square second minus 2. So, and we know, so this is the base unit of work done or energy, because work energies are the same thing. Whenever there is a work is done, there will be energy either transferred or stored. And we know the unit of energy is joule. So basically joule is equivalent to kilogram meter square second raised to power minus 2. If we are representing a power, so we know power is equals to work divided by time. So this is a formula for the power. What about the unit? Unit of work is joule and unit of time is second. But joule is not the SI unit. The joule is basically joule is not the base unit. SI is there but not the base. So it can be represented as kilogram meter square second raised to power minus 2. So in place of joule, I can write kilogram meter square second minus 2, and this is divided by second. So this second will move up. So it will be kilogram meter square second raised to power minus 3. So that is equivalent to unit of power is watt. So it means watt is equivalent to kilogram meter square second raised to power minus 3. Is it clear this example? So you should be able to represent the quantities in terms of base units. So first step, writing a formula, second step, writing their units, and then convert them into base unit. So example, if I say momentum. So first we'll write the formula for momentum. We know momentum is equals to force multiplied by distance. So when Force is multiplied by distance, we call that as momentum. So this is a formula. Then we write the unit first. Unit of force or momentum is equals to not force multiplied by distance, mass multiplied by velocity. By mistake, I was recalling for work done, but it is mass multiplied by velocity. So mass into velocity is momentum. So what is the unit of the mass? Unit of mass is kilogram, and unit of velocity or speed, it is meter per second. So this will turn out to be kilogram multiplied by meter per second. So when we simplify kilogram, meter divided by second, so this will move up. So it will be kilogram meter second minus 1. Is it clear, this example? So the physical quantity, a physical quantity can be a scalar quantity, can be a vector quantity. A scalar quantity means it is having a magnitude and unit but no direction. Whereas vector quantity completely represented by a magnitude, unit and direction. So when we represent a quantity by all the three parameters, we call that as a vector. Like example, if I say today's temperature is 33 degrees centigrade. So this 33 is a magnitude and degree centigrade or Celsius is a unit. But I don't say in the direction of east, west, north, south, upward, downward. So there is no specific direction. That's why we call that as a scalar quantity. Whereas a vector quantity is having a magnitude, unit as well as direction. Example, if I say a force of 30 Newton is applied in the direction of east. So 30 is representing a magnitude, Newton is representing a unit, and east is representing a direction. So a quantity which is represented by all the three parameters, that quantity is known as a vector quantity. So I want everyone to participate and state the quantity. Like example, time, scalar or vector? So time is a scalar quantity. You can use the screen annotation and type scalar in front of time. The screen annotation is enabled, so you can use that and state whether a time is a scalar quantity or a vector quantity. So time is a scalar quantity, so in front of that you will write scalar. Same way, if I say mass, scalar or vector? Mass of an object. Just type in front of mass whether it's a scalar or a vector. Temperature, force, weight, speed, velocity, acceleration, distance, displacement, energy or work done, power. So time is a scalar, that's right. Mass is scalar, correct. Temperature is scalar. Force is a vector. Weight is a vector. Speed is scalar. Velocity vector. Acceleration vector. What about distance? Distance, scalar or vector? The distance is scalar, that's right. Displacement is a vector. Work and energy. We say a work is 30 joules or 50 joule, or a energy transfer is. So we don't specify direction, that's right. Power. We mention power like 40 watts, 100 watts, 80 watts, but we don't say a specific direction. So it is also scalar. And the last one, density, the mass present in unit volume. Density is not a vector quantity, it is a scalar quantity because we do not specify a direction. We say density is 50 kilogram, 30 kilogram, but you do not mention any specific direction. So these are some examples of scalar and vector quantities. Then thank you for your participation. Then we have graphs and equation. So graphs and equation in mathematics, you have learned a equation of a straight line. It depends on what is the shape of the graph. Like this is y-axis and x-axis, and it is a straight line which is passing through a region. So the equation of this line is equals to y is equals to mx plus c, and where what is c here? C is called a y-intercept. The term y-intercept means the point where it touches the y-axis, that's called y-intercept. And in this example, c is equals to 0. So basically the equation is y is equals to mx. So for a straight line which is passing through a region, the equation will be y is equals to mx. But if it was a straight line but not passing through a region, it was touching the y-axis, positive y-axis, and the graph line was like this, then because it is touching a y-axis, so y is equals to, the equation will be equal to y is equals to mx plus c. And what is c? This value is known as c. Here this was c, but because it was on the origin, so c was 0. And it can be below the origin as well. So this is a negative y-intercept. So equation of this line will be equal to y is equals to mx minus c, because the y-intercept is negative. It is touching the negative y-axis. So y is equals to mx minus c plus c, and y is equals to mx plus c. So why these equations are important? Because using this equation, you can recognize or identify the type of the graph. How you can identify the type of the graph? If the where m in this example m is a gradient of the graph, where m is equals to gradient or slope of this graph. So example, if the gradient is constant and y-intercept is 0, it means the graph line will be straight, which is passing through origin. So if the gradient is constant and y-intercept is 0, then what should be the shape of the graph? It will be a, because sometime using the equation you have to work out the shape of the graph. So it will be a straight line which will pass through origin. So this is y-axis and this one is x-axis. And how we can show this, that graph is possible? For example, if I say we have the equation h is equals to 2g or we have this equation s is equals to ut plus half at square, so it will be h is equals to 1 by 2 gt square. This is the equation. H is equals to 1 by 2 gt square, where g is a acceleration due to gravity or constant, which is a constant 9.81. The question is show that or predict the shape of the graph between h and t square, and h is on y-axis and t square is on x-axis. So the question is that if we want to plot a graph between t square and h, and in which h is on y-axis and t square is on x-axis, what will be the shape of the graph? So how we can predict the shape of the graph? So what we do, we will compare with the equation of a straight line. What is the equation of straight line? The equation of straight line is y is equals to mx plus c. And our equation which is given, the equation which is given to us, that equation is h is equals to 1 by 2 g t square. That is the equation given to us. So when I compare this with the equation of straight line, so if on y-axis I have h, on the y-axis if I have h, on x-axis if I have t square, so what will be my gradient according to this? The gradient will be equal to g by 2 or half g. And what about the y-intercept? Because nothing is added here, so it means the y-intercept is 0. So if y-intercept is 0 and gradient is g by 2, g is constant, so any constant divided by 2, what you will get? You will get gradient as constant. So when gradient is constant and the y-intercept is 0, so what will be the shape of this graph line? So it will be a straight line which is passing through origin. Is it clear that how I worked out the graph using the equation? So equation is given to us, which is h is equals to half gt square. So I compare this equation with a straight line equation, which is y is equals to mx plus c. So on y-axis, if I'm plotting the height, on x-axis, if I'm plotting the time square, then my gradient will be equal to g by 2. and we know g is constant. So if any constant divided by 2, the result will remain constant. So it means that the gradient of this line will be constant and the y-intercept is 0 as we compare. So it will be a straight line from origin. Is it clear, this part? Another example, we have the equation 2gh is equals to v square, and we have to show that where g is equals to constant acceleration due to gravity, which is a constant, predict the shape of graph when we have h on y-axis and v square on x-axis. So we have h on y-axis and we have v square on x-axis, and we have this equation. So 2gh is equals to v square, and the equation of a straight line, that is y is equals to mx plus c. So the quantity, basically I cannot compare this now. Why I cannot compare this now? Because the quantity which is on y-axis should be on the left hand side of equal to. So the quantity which is on y-axis is height. So height should be separate. So first what I have to do, I have to rearrange this equation. So when I rearrange this equation, 2g is multiplied, other side it will divide. So it will come out h is equals to 1 by 2g into v square. Is it clear? Is it clear what I did? Because I cannot compare right now. Why I cannot compare them? Because the quantity on the y-axis should be separate. But here we have quantity on y-axis is height, but height is multiplied by 2g. So we have to remove this 2g, it's multiplied, other side it will be divided. Now we compare. So if on y-axis we have the height, on x-axis we have v square. So what will be our gradient? Our gradient will be 1 by 2g. So that means it's a constant. And what about the y-intercept? Because nothing is added here. So y-intercept will be 0. So it will, again it will be a straight line which is passing through origin. Is it clear? Same way, sometime the equation is not as it is. There's a different parameters. You are plotting a graph. Like example, t is equals to 2 pi under root L divided by G, and where L is a length which is constant, or where G is a gravity which is constant, and L is a length. Now predict the shape for graph between t square and L, and t square is on y-axis, on L is on x-axis. So we have to predict the shape of a graph where t square is on y-axis and L is on x-axis. So how we can predict? But when you see this equation, you don't see t square. According to the equation, we have t is equals to 2 pi under root L divided by G. and you want a graph for t square and L. So what you have to do first, you have to square, because you have to make the equation for t square. So we will square both sides. So when we square both sides, this will be t square. This will be 4 pi square L divided by G. Now you have equation for t square and L. Then you will compare with the equation of straight line, which is y is equals to mx plus c. So on y-axis, if we have t square, on x-axis, if we have L, our gradient will be 4, which is constant, pi square, constant, pi 3.14, and g is constant. So our gradient will be a constant. And what about y-intercept? It will be 0, because nothing is added. That shows the y-intercept is 0. So it will be a straight line which is passing through origin. Is it clear? So sometime you have to plot a graph for different parameters. So you have to rearrange the equation according to the question, because in the question you are plotting a graph for t square in L, but the equation is given for t. So how to make t into t square? So you will square both sides, and then you will have t square. You compare with the equation of straight line. Is it clear? So this was about the graphs. So we started with an introduction of mechanics in material unit 1, the SI quantities. We discussed SI quantities and how to represent them as drive quantity, and then later part we discuss about the graphs. The next session will discuss about experimental uncertainties and so on. Any question related to the class today? So I'll end the session and share this recording with you.